Chapter number 7, that is thermochemistry. Question number 18. Question number 18 is about if the heat of combustion of C2H2, H2 and C2H6 are minus 337.2, minus 68.3 and minus 372.8 kilocalories respectively, then calculate the heat of the following reaction. So the reaction for all the combustions are not given, just the required equation is given in a question. So you have to make equations yourself. So first is C2H2. The combustion of C2H2 means the burning in the presence of oxygen. The sole product of combustion are CO2 plus H2. Now you have to balance the equation. 2 atoms of carbon, so in a product write 2 atoms of carbon, 2 atoms of hydrogen. In a product you can see 2 atoms of hydrogen, so no need to write any value, any digit here. 2 atoms of oxygen, but in a product you can see 2 2s are 4 oxygens, and here you can see 1 oxygen atom. So total are 5 oxygen atoms, but in a reactant there are just 2. So how you can make it 5? So 5 by 2. This 2 will be cancelled out with this 2. So here in a reactant there are 5 atoms of oxygen. Enthalpy change is minus 337.2 kilocalories, that is given in our question. Second heat of combustion is for H2. Burning in the presence of oxygen, it will give you water, no carbon dioxide, because no any of the reactant having carbon. So 2 atoms of hydrogen in a product, 2 atoms of hydrogen in a reactant, 2 atoms of oxygen in a reactant, but only 1 atom of oxygen in a product. So we have to balance this. How we can balance this equation? We have to take half of this oxygen gas. This 2 will be cancelled out with this 2. So enthalpy change for this reaction is minus 68.3 kilocalories. Next is C2H6. The combustion of C2H6 will give you carbon dioxide plus water. Balance this equation. 2 atoms of carbon in a reactant, 1 atom of carbon in product, so you have to write here 2. 6 atoms of hydrogen in a reactant, 2 atoms of hydrogen in a product, so you have to write here 3. 3 2s are 6, and here you can see 6 hydrogen atoms. Oxygens are here, 2 atoms of oxygen in a product. There are 2 2s are 4 oxygens, and 3 2s are 6 sorry, not 3 2s are 6, only 3 oxygens. So 4 plus 3 will be 7 oxygen atoms. So you have to balance the equation by writing here 7 by 2. 2 will be cancelled out with the 2. So 7 atoms of oxygen in a reactant and 7 atoms of oxygen in a product. These are the equations. Required equation is C2H5 plus 2H2. Product is C2H6. All are gases. In a thermochemistry, it is very important to write the state of the compound. So in this, all the compounds are gases. How we can make this equation? You have to add, you have to subtract, you have to multiply. Whatever you can do, you have to do to make a equation. So the important thing in this is, here you have to write C2H2, not C2H5, C2H2. So here you can see in this equation there is C2H2 in equation number 1. You need H2, so here you can see in equation number 2 there is H2, and then you need C2H6 on the product side, and in third equation you can see C2H6 is present, but on the reactant size. So which proves that you have to subtract this equation number 3 from equation number 1 and sum of the equation number 1 and 2, because you need this C2H6 on the product side. So if it will be in a with the minus sign, then it will move on the product side. So you have to add equation number 1 and equation number 2 and subtract equation number 3. Then you will get your required equation. Enthalpy change for this third equation is minus 372.8 kilocalories. So first we are going to add these two equations. Before adding the equation number 1 and the equation number 2, you can see in a required equation the number of moles of hydrogen gas are 2. But in a equation number 2, we just have a 1 mole of hydrogen gas. So we have to multiply the second equation with the 2. If we are multiplying the equation, then its enthalpy will also multiplied with the 2. So this will be equals to, first I am writing equation number 1, then I will write the equation number 2 with the multiplication. So first equation is C2H2, this is gas, 5 by 2 oxygen moles. This is also a gas and the product is carbon dioxide, 2 moles of carbon dioxide gas plus 1 mole of water gas as a steam, as a gas. Enthalpy change is minus 337.2 kilocalories. Second equation is multiplied with this 2, so that will be equals to 2H2 plus O2, that will be equals to 2H2O. 2H2O. If you can see here, 2 multiply with this hydrogen gas, so it will be 2H2O. If 2 is multiplied with this half, so 2 divided by 2 will be cancelled out. Only 1 mole of oxygen gas will remain and 2 moles of hydrogen gas and 2 moles of water. Enthalpy change will also be multiplied with the 2, so it will be equals to minus 136.6 kilocalories. When there are 2 moles of hydrogen gas, then 1 mole of oxygen gas is required. If there is 1 mole of hydrogen gas, then you need half mole of oxygen gas. Now add these two equations. By adding these two equations, you will get C2H2 plus 2H2 plus. When you are going to add these two oxygen's values, then it will be equals to 5 by 2 plus 1 by 1. So 1 5s are 5, 2 1s are 2, 2 1s are 2. So 5 plus 2 will be equals to 7. This is a simple mathematics divided by 2. So 7 by 2 will be the answer. So you have to write here 7 by 2 moles of oxygen gas. Clear? How you are going to add this? You have to use simple mathematical rule. Product addition, 2 moles of carbon dioxide plus 1 mole of this water molecule and 2 moles of this, so not water molecule, this is a gas, water, this 1 mole and this 2, it will be equals to 3H2O. Add the enthalpies, so that will be equals to minus 473.8, because this is going to be add, so minus plus minus, so you have to minus the values but the sign of the bigger value. Bigger value is this one and this value having a minus sign. So here you have to write minus 473.8 kilocalorie. Now you have to subtract the equation number 3 from this new equation. Equation number 3 is C2H6 as a gas plus 7 by 2 oxygen gas. The product is 2CO2 plus 3H2O. Enthalpy change is this one. Enthalpy change for this reaction is minus 372.8 kilocalories. So you have to subtract this equation. So sign will be changed as a minus, 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 and here if I write here minus, then minus plus minus minus will be equals to plus. So I am writing here plus, because if I am writing here minus, then minus minus will be equals to plus. So I am directly writing here plus. So add the equations, subtract the equation. This is in a positive, so C2H2. This is also in a positive, so you have to write 2H2. This is in a positive and this is in a negative. So cancel out these both oxygens from these two equations. This is in a positive. This carbon dioxide molecule is in a negative. Cancel out this water is in a positive and this water gas is in a negative. So cancel out. Here you can see this is in a negative. So this will be moved on the other side of equation because you cannot cancel out this because there is no another molecule that is in a positive. So you have to move it. C2H6. Now this is a required equation. We have to calculate the enthalpy change for this reaction. So minus, new sign is plus. So minus plus minus, you have to minus the enthalpies sign for the bigger value having a minus sign, so you have to put minus, but subtract these values as minus 473.8 minus 372.8. the answer will be 101 kilocalories per mole. Next, problem number 19. Graphite and diamond are two forms of carbon. The enthalpy of combustion of graphite, this carbon is for graphite. Graphite is a giant covalent compound and all the atoms of the graphite are carbons. So the combustion of this graphite means the burning in the presence of oxygen will give you CO2 as a gas. This is in graphite, this is oxygen gas, and your product is carbon dioxide gas. Enthalpy change is minus 393.51 kilojoule per mole. Next is the combustion of diamond. Diamond is also graphite, a giant covalent molecule containing all the atoms, 100% carbon atoms. All the atoms in a diamond have carbon as like in a graphite. So the combustion of this diamond in the presence of oxygen will provide you carbon dioxide gas. Enthalpy change for this reaction is minus 395.41 kilojoule per mole. You have to calculate the enthalpy change for this reaction. Graphite to diamond. When graphite is converting into a diamond, then how much enthalpy change will be observed? So you have to calculate enthalpy change for this reaction. How you are going to calculate this? If you are subtracting equation number 2 from equation number 1, then you will get your required product because you need this diamond on the product side. So if it will be with the minus sign, then it will be move on the product side. So we are going to subtract this. If you are going to subtract the equation number 2 from equation number 1, you will get your required product. So change the sign, minus, 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 and here you have to write plus. Because in the previous example, I have explained you how it will be positive. So these values will be cancelled out because one in a positive and one with the negative sign. This carbon dioxide gas and a carbon dioxide gas will be cancelled out. So minus plus minus, you have to subtract the value, but the sign for the bigger value, and this is a bigger value, this bigger value having a positive sign. So enthalpy change will be equals to 1.9 kilojoule per mole with a positive sign. When you want to convert this graphite into a diamond, this amount of energy will be absorbed.